Hi there, in this video I'm going to go through the derivative of exponential functions. Okay, so let me title this Derivative of Exponential Functions. So let me take a red pen and a ruler, underline this. Let me first give you the standard result. So if y is equal to e to the power of x, dy over dx is e to the x. Okay, so that's the standard result for when you differentiate the exponential function e to the x. Okay. Let me also give you an additional result. So an additional result. So this additional result is based on the standard results. So if y is equal to a e to the power ux. Okay, so just as in my previous videos, so in my previous video on the derivative of trigonometric functions, okay, so I quoted additional results involving a and ux. So likewise here, a is a constant, ux is a function of x, and I'm going to use the chain rule in order to come up with the derivative of such a function. So where a is a constant and ux is a function of x. So let's come up with the derivative of this result, and let's come up with that result using the chain rule. So let me go through the steps to come up with the derivative using the chain rule. So in step number 1, let me quote the chain rule. So by chain rule, to work out the gradient function dy over dx, it's dy by du multiplied by du over dx. Okay, so step number 1, quote your chain rule. Okay. In step number 2, let me calculate dy over du based on y equals a e to the ux. Okay. So y is a e to the power u. Okay. My u is the shorthand for ux. So let me make a note of that. U is my shorthand for ux. So let's work out dy by du. So bearing in mind a is a constant and ux is a function of x, so if I differentiate such a function with respect to u, we're going to have a e to the power u. Okay, so we're just differentiating with respect to u here. And in the final step, step number 3, let me replace dy by du by our answer here, a e to the u. So dy by dx is equal to dy over du, which is a e to the power u, which is the same as ux, multiplied by du over dx. Okay, so this is the result for the derivative for a e to the ux, and a is a constant in this function, ux is a function of x. So if a is a constant, ux is a function of x, then you can apply this chain rule related result. However, if a is not a constant, you may need to use the product or quotient rule. Okay? So let's try some examples. So fresh page, I think. So in example number 1, let me take a red pen and a ruler. Okay, so let's try some examples here. So in this case, question is to find dy by dx. And in part A, so let's try a number of examples. Firstly, y is equal to 3e to the power 2x squared plus 1. So 3e to the power 2x squared plus 1. Now, as I said in my earlier videos on differentiation, try not to learn or try not to memorize so many results, okay? So going back to the result that we derived, the chain rule related result, I would say don't memorize the result, just have an understanding of what the result is trying to say. So the result is saying if a is a constant and ux is a function of x, the derivative dy over dx it's the same term, ae to the ux, but you need to multiply by du over dx. Okay, so don't memorize the result, just think about what the result is trying to say. So dy over dx is the same term, but you need to multiply by du over dx, and u, remember, is the power when it comes to exponential functions. In the previous video, u is the angle for trigonometric functions. If you haven't watched that previous video on trigonometric derivatives, I would encourage you to do so, okay? But over here, we're dealing with exponential functions. U is the power of your exponential function. So it's d by dx, in other words, of the power, okay? So going back to this example, part A, the term in front is a constant. So A is 3 is a constant. That means that we can apply the chain rule related result. So remember what that result is trying to say. It's the same term, so 3e to the 2x squared plus 1. But you need to multiply by d by dx of ux, and ux is the power. Okay, so the power being 2x squared plus 1, the power of your exponential function. Okay, so now it's about tidying up. So when we differentiate 2x squared plus 1, that is 4x. So dy over dx is equal to 4x times 3, 12x, e to the power 2x squared plus 1. That is your final answer. Okay? Right, let's try some more. Y is equal to, let's think about this one. Okay? So in a previous video, I went through the derivatives of trigonometric functions. So let me combine this with a trigonometric function. How about 5e to the power sine 2x? Okay? So let's think about this one. The term in front of the function, the exponential, is 5. So that is our a, say. A equals 5. 5 is a constant. We can use the chain rule related result. So here goes. dy over dx is equal to, remember what the result is trying to say. It's the same term, so 5e to the power sine 2x, but you need to multiply by d by dx of, and ux is the power being sine 2x. Okay? So now it's about tidying up. So let's differentiate this term outside, d by dx of sine 2x. So using the same approach, a similar approach for trigonometric functions, the term in front of my trigonometric function, so if I take a green pen, is 1, okay? 1 is a constant, so we can use the chain rule related result for trigonometric functions. So when I differentiate sine, it's a cos, so it's a cos 2x, but again multiply by d by dx, and ux for trigonometrics is the angle, so it's 2x. Okay? So if you're unsure about this derivative, I have created a video, okay, one of my previous videos on trigonometric differentiation, so be sure to watch that video for more examples. So let's get back to this example. D by dx of 2x is 2, so let's have a note of that. So dy over dx will be 2 times 5 is 10, okay, so it's going to be 10 e to the power sine 2x with, and don't forget, cos 2x. Okay, so that is a solution for the derivative of 5e to the sine 2x. Let's try another one just to test ourselves. Y is equal to 10x e to the power, okay, cos x. So 10x e to the power cos x. So let's think about which rules we're going to use. The term in front of the exponential function, so a say, is 10x. Now 10x is not a constant, so we can't use the chain rule related result. We need to use, in this case, the product rule. So I'm going to take u to be 10x and v to be the remaining term, e to the power cos x. Okay? So step number 1, let me quote the product rule. So by product rule, dy by dx, that's v, du by dx, plus u dv over dx. Okay. In the second step, let me do a side calculation. So u in this case is 10x, and let me calculate du over dx firstly. So du over dx, when I differentiate 10x, it's simply 10. Okay. Let me follow this up with another side calculation on the side. V I've taken to be e to the power cos x, and let's think about dv over dx. Okay, so let's practice again. Now looking at this term over here, e to the power cos x, the term in front of the function is 1, so Ra is 1. 1 is a constant, so we can use the chain rule related result. So remember what the result is saying for the exponential case. When I differentiate the exponential, it's the same term, but you need to multiply by d by dx, and ux for exponentials is the power is cos x. Okay, so going back to the derivatives of trigonometric functions, when I differentiate cos, that's the standard result, it's minus sine. So let me continue. dv over dx is minus sine x e to the power cos x. So that is the derivative for dv over dx. Okay. Now let me substitute the results for du over dx as well as dv over dx into my product rule. So let's see what we have. So step number 3, dy over dx is equal to, now going back to the product rule, it's v is e to the power cos x, so let's jot down that, e to the power cos x, multiplied by du over dx being 10, plus, so u is 10x, multiplied by dv over dx is minus sine x e to the cos x. Okay, so if I expand the brackets, dy over dx will be, so by expansion, 10 times e to the cos x, 10e to the cos x, and 10x times minus sine x e to the cos x is minus 10x, okay, sine x e to the cos x. And in my next step, let me factorize. So I have 10s here. Let me take a common factor of 10. And also I have a common term of e to the cos x. So if I take that out also, and include that as my common factor, I'm left with 1 minus x sine x. Okay? So that completes this example, and here are the steps involved to do part C. Okay? And that also completes this video also, sadly. So I hope you enjoyed this video. A like would be very much appreciated. Do practice related questions, and I hope to see you again soon.